Welcome, everyone. My name is Willian, as I mentioned. I'm a software engineer at Red Hat and also a teacher at a college. So today I'm going to talk about effortlessly scale your application using OpenShift Serverless. And what we are going to talk today is what is OpenShift Serverless, which services are available on OpenShift Serverless, and we're going to have a hands-on with some videos showing how to deploy your application, how you can scale up and down, or how it can be scaled up and down automatically without any action from you. Okay, so what is OpenShift Serverless? So OpenShift Serverless is a Kubernetes-native building block to create, deploy serverless and event-driven application effortlessly. It can automatically scale up and down your application on demand. You don't need to have any manual action on it. It's all based on the Knative project. So if you want to install it on Kubernetes, you can use the Knative project. All right, let's see some features from OpenShift Serverless. So the first one is function. So a function is what the name says. You define your function using one of the supported languages. Then you use a Knative command line to build and deploy your application. You don't need to set up any container information or any configuration, service, routing. You don't need to do it. You can just build your function and use Knative to build and deploy a container without any interaction from you. Okay, the other feature is serving. So serving is almost the same, but you build your whole application and serve it through serverless. So you don't need to worry about routing. You don't need to worry about services. You don't need to worry about OpenShift resources or Kubernetes resources. Serverless will take care of it for you, and it will take care for scaling up and scaling down configuration. And then we have eventing. So eventing is a way to consume things from event producers on event consumers. So you have something in the middle that can receive any event and forward it to a consumer depending on some rules, and these rules are the triggers. So you can send your requests or your events to different consumers based on the roles defined on the triggers. All right, so this is the basics of serverless. Now let's take a look at our demo. So our demo will use OpenShift Local, which is formerly known as code-ready containers. So this is why when you download, you have the command line called CRC. So it comes from code-ready containers. And I have installed serverless on it. So all the code is available on my GitHub. You can download, you can install code-ready containers, you can install serverless, and the demo will run out of the box, just like in the videos. This is our application. So we're going to have an API. This API will receive requests. This is a pod running, and then it will forward the request to the broker. The broker will trigger to the worker. So the API and the worker are the serving functions, and the broker is the eventing function. Okay, here's the code for our API. So we have one endpoint. I have removed some of the lines that were just logging information. If you download the code on GitHub, you have access to all the code. But this is the core. So what is important here? We need to know the broker address to forward the request. We need to set up the headers based on cloud events, or the broker will not accept it. We format the data and then submit the data to the broker. And then we return 202 accepted to the user, as this is an asynchronous application. And here's our worker. So our worker have just one endpoint that will receive the request and send it for background processing to release the thread of Fast API, which is what I'm using in the back here. And the worker needs to also return a 202 accepted to the broker, or the broker will keep trying to send the request to the worker. So the worker needs to let the broker know that it received the request without problems. Otherwise, if it has some problems, it will send the request to a dead letter sync. So you can set up a dead letter sync telling, hey, something happened here that the worker did not receive the request. What should I do with this? So you can handle it. And then we have our work, which is an IO-bound function that in this case will do just a sleep, but it could be something that is IO-bound to process in the background. All right, so let's take a look on how we deploy it. And these are the YAML files. So obviously, you cannot read it because it's small, but I put it this way just to show you that it's the same as our diagram of the application. So we have the API here, which has its YAML and a config map that will have the address of the broker. Then we have the YAML for the broker. Then we have the YAML for the trigger, which will set the rules to forward the information to the worker. And then we have a YAML for the worker. So here we have a serving service, and there we have a serving service. Then we have the broker, the trigger, mimicking the diagram of our application. All right, let's zoom into the worker YAML. So in the worker YAML, there are two configurations, two annotations. One is the minimum scale. So I'm setting that to 1, or serverless would scale our application to 0. It means that when we send a request, it will take some seconds until serverless spawn a new pod and handles the request. So I'm leaving at least one pod up so it can handle the request right away. But you can modify that. And then the max scale to 5. So if we have, for example, too many requests, the serverless will handle that automatically and spawn new servers, and it will be handled by the application. All right, so these are the steps to run our application. First thing is deploy your infrastructure. So here I deployed CRC, I installed serverless, and I have set configuration to allow pushing to the local registry, so I don't need to install or push my image to any other services, so I can push it to OpenShift. Then I have the build step, which I will build and deploy the application, just as a normal CI/CD pipeline. And then the last one is the deploy. All right, so let's take a look at the videos about the demo. The first one is the build and push. Here you can see that I'm logging into the OpenShift instance, and then I'll build the container locally, just as you build your container. Right after that, I'm tagging the build I just did and pushing to the registry of the OpenShift. All right, so our application is now available in the container registry of OpenShift. So let's deploy it. And deploying means logging into the cluster and repeating all the OC apply commands, just like we would do, or the kubectl apply commands, just like you would do on any deploy. So deploy the API, deploy the config map, deploy the worker, deploy the broker, and deploy the trigger. After we deploy everything, our application is up and running on OpenShift. Alrighty, so let's test our application now that it's up and running. So here on the right side, you're going to see the logs for the API and the worker. So I'm taking the names of the pods that are running, and I'm setting to watch the logs there on the right side. So I'm watching on the top the API, and on the bottom the worker. Now I'm going to send a curl request to the application. First I need the address of the API. So I'm checking what serverless is serving. I'm taking the address, and I'm going to send a curl command to the API address. And what I'm doing is I'm asking the application to clean up my bedroom, which is a nice work to have, and it takes like 5 seconds. So on the top you have the API receiving it. So you see the logs here. It received the work and forwarded to the broker. Then the broker, based on the trigger, forward it to the worker. The worker started to clean my bedroom. And then after 5 seconds, it finished to clean my bedroom. And the work is completed. So everything working out of the box. Great. Now, let's see a good feature about serverless, which is auto-scaling, which is the purpose of this talk. So it can scale up your application up and down without any manual intervention. So on the right side, you see my console for the OpenShift. It's running 1 worker pod. And on the left side, I'm sending 300 requests for the worker in one single command. So you're going to see serverless spawning new pods on the right side to handle all the requests. So now it's handling all my 300 requests in 3 pods. And as soon as it's completed, serverless will spawn, will remove the unneeded pods. So now it's terminating the 2 pods that are not needed because I have set it minimum 1 and maximum 5. So it had to spawn 2 new pods to handle my requests. And when there were no more requests, it scaled down to 1 again. And now my application is running with 1 pod again. All right. So that's it for my demo. You can download the code here and run it locally. You can play with it and set up your application to work with serverless. So any questions? I think we have 1 or 2 minutes.
So if you are like, for example, flooding the server with like 300 requests, right, and then handles it, how you get the data back? Like, is it written in like some central database where you like read it, or how that works?
Yeah, it will depend on your application. So here it's doing some IO-intensive work. So it will do the IO-intensive work, send the results to a database or whatever. It's async, and you can retrieve the data later. So the question was how to handle the outputs. Oh, I'm sorry.
Okay, great presentation. I just wanted to ask, how does it automatically scale up the pods? Like, does it automatically provision new nodes using some sort of metrics, or how does that work?
Yeah, there are some basic metrics for the serverless. It will not create new nodes, but only pods on the nodes. It will depend on the resource you have available for the namespace. But you can tweak the configuration of your namespace to know how to trigger new pods or not. It's based on local configurations of your namespace and application.
I was just going to add that since I've worked on Kubernetes for a while, that's the right way to do it, because when serverless creates new nodes, you could then configure or new pods. Then Kubernetes has a node auto-scaling features. And so it's usually driven off of pods that are created but not scheduled, which drives the demand for new nodes to be spawned up, if you have the right configuration. Yeah, it's basically in the queue. So there is a time delay. There's an art to playing with those right settings, but that's the gist of how it works.
Yeah, thank you. All right, we are out of time, so thank you for coming and for the question, and I hope you enjoy the demo and try it.